I'm Susan Israel, and this is Catherine Duff, and we are the founders of Studio 2 Sustain. As architects who are passionate about the environment, we have been working on projects to inspire and teach sustainable living.
The Energy Necklace Education Project is a K-12 curriculum that uses sculpture as a curriculum armature to teach students about the environment and about renewable energy.
The Energy Necklace curriculum is an interdisciplinary curriculum which uses the hands-on process of building energy sculptures to reinforce the learning in the classroom and to engage a wider range of learners in STEM education. STEM stands for Science, Technology, Engineering, and Math. And we also add marine science, renewable energy, environmental science, building sciences as part of that science package. We began piloting the curriculum at Newton South High School with Carol Ober in her 3D animation class. In 2011, we added renewable energy, which is a technology class taught by Matt Briggs. We began this as a collaboration between both classes where we went in, we introduced the energy necklace, we introduced concepts such as biomimicry and blade design and carbon fiber and some of the renewable energies, some cutting-edge solar technology. And we were able to bring in some samples for the students and some slides and also give them some artistic precedents for what they were going to work on. The students started out by making a 5-minute sketch so that they came to the table with some initial idea on paper. The students then spent over 2 hours working together in sketch models with the two classes together in the lab, working with reclaimed materials of various sorts like paper and cardboard and sailcloth and glue guns and staples, and really just everything was intended to move but to really not have motors operating them.
And have some suction cups on it, and then it'll be able to roll while placing.
Because what's going to be the hardest part is getting like the gears, put together, and we can just have that together. Show someone so spin one on top and have the wheel spin.
Yeah.
This is a sample of one of the sketch sculptures that was done during that initial, we call it a charrette, which is an architectural term. Matt called it a deep dive, but it was a total immersion. Here it is, kids, go do it, with just our introduction. And it was a wonderful day. They got very far. As you can see, this team had an idea about a flower and bringing that idea of the landscape into the turbine itself.
And I also like the reversal. It's a little bit of a reversal.
I'm close to finishing it, but we were going to have two turbines on the side, and this is the second one. It's not finished yet. So if you could imagine that, these two would generate electricity. There would be either front one or one sticking up at the top that would also be able to generate electricity. It's just kind of modeled after a plan.
After that first day, both classes then went to work in the same medium in which they were planning to work. And so the 3D animation class continued on working in virtual space and sketches, and the renewable energy class worked on the models some more, and then they went back to study renewable energy technology in a classroom setting.
And what was so interesting about the role of the arts in the process of making an energy sculpture was to see how the initial ideas were incorporated and elaborated in the final sketch models that resulted from that initial 3-hour in-school field trip. And the ideas ranged in scope from animation, literal animation. Some of the sculptures looked like animals or people, or they actually took a figure like the flower from the landscape, to ideas about renewable energy that were incorporated in a more abstract manner.
One thing that I really appreciated about the students' projects is how many of them were personal. They really took something meaningful in their lives and combined it with all of the other information that we were presenting to produce something unique. So in the 3D animation class, 2 students had talked about the teacup ride and how they had turned that into an energy sculpture driven by the wind. It was such a personal idea and full of delight. So I really appreciated that, and the bicycle sculpture we talked about. There were several cars. Several students had taken the project and extended it beyond the initial description of a fixed sculpture and made vehicles which were powered by wind and sometimes solar. Many of the students incorporated solar along with the wind. We have what we call the chandelier, and it's concentric circles, and you can see there are strips that hang down from it which can gather solar energy as well as act as wind blades.
Here, and it would spin this thing, which would spin this axle.
At the beginning of the joint project with the two classes, we showed the students a lot of examples of both public sculpture and materials that are being used and developed to get on top of some of these environmental crises. And it was interesting to see these fabrics symbolically captured in the sketch models. For instance, one three-bladed wind turbine, vertical wind turbine, used sailcloth on the blades and created this both visually striking, super lightweight, and very profound, what is otherwise a simple vertical wind turbine.
This idea from his initial sketch like this.
The attention that has been lavished on us by the visiting architects, by collaborating with the technology department, I think that has made them take it much more seriously. I found that high school students often tend to rush through one design, one idea. This has somehow cajoled them, encouraged them into making multiple versions of any different idea. They don't complain when I ask them to, try another take at it. They are, and I think that's a sign of true engagement with the project, is they are willingly, on their own, doing one sketch after another, and making minor variations and then thinking about it, stepping away, trying a different approach. It has made a huge difference.
Gears are right here.
Gears that would go inside, it'd probably be like a tube that would go down, and then the gears would spin it, and then you'd spin these wheels.
One of the virtues of this curriculum is that it keeps art education in schools where budgets are being cut everywhere and art is the first thing to go. We are able to preserve art education. And art education is important. It's not just an add-on or something that's decorative or something you do for fun after you go to school or work. It's really integral to the process of learning how to problem solve, how to think creatively, how to persevere down a nonlinear path. Art is one of the only places where students really can create the agenda as opposed to find some answer that somebody already has figured out for them.
You do have these sort of guidelines to keep you on track, but just like the whole idea comes from you. It's not anyone else's. It's just purely your own idea.
The pilots that are currently underway, what we've observed is that all students participating in the solutions, not just the technically skilled students or the mathematics students or the artistic students. When that sail goes up, that boat launches forward. The end products are diverse, they're creative, they're collaborative, and they all incorporate an idea about renewable energy.
Well, okay, so my sculpture was like, it was just a big tube, and then it had 4 wings, 2 on the left side and 2 on the right side. And then I had Egyptian snakes sort of on the top and the bottom. And the reason I had the wings was because they were like bird wings, and when birds flap their wings, they capture a lot of the wind energy.
It was 3 objects, and they were rotating around a circle, and it was just a huge pole that was supporting it, and so I kind of drew my inspiration from that.
We talked about at the beginning of the project using inspiration and looking to perhaps history or perhaps real-life sculptures or nature or whatever it is, but grabbing some inspiration for a project, some solid inspiration which we could cite almost. And for me, that was the history and the themes involved in the environmental issues. My project dealt with imagery which reference the Industrial Revolution.
You could have a little bit of fun by just showing the ribs. So you just open up, make it more transparent. This pilot, that's a combination of the renewable energy class and the 3D animation class, is just the start of an interdisciplinary curriculum that could, in fact, then incorporate sculpture classes, math classes, physics classes. And as we move forward with this pilot at Newton South, we hope to include many more students and many more classes in a full interdisciplinary rollout.
See them in movement, they're going to transform into something else. They'll, for one thing, they're going to occupy an orb in space. When they're moving, you think about what's that shape that they define. It's actually a sphere. And then we were very mindful in thinking about this curriculum that schools and teachers are already overloaded with requirements by state mandates, district mandates, department mandates, and we understand that every teacher has a full curriculum already, and that there isn't a vacuum that we're coming in to fill. So we have designed this as a series of slivers of adjuncts which teachers can then take. They can augment the material that they already have with this specific information that they want from us. They don't need to use some prefix, complete curriculum, but they'll take the pieces that they need.
Well, the kites are really fun right now, and I'm really excited to fly them, and I can't wait. And there's no better, at least for us humans, there's no better way to understand something than to experiment. If you experiment with something in the real world, you can experiment on the computer, but it doesn't have the same physical, you can't actually test something. You have to create it yourself. You have to make the animation or whatever, and it doesn't necessarily conform to the laws of physics. And I think the best way to do that was to experiment with it, actually create it in real life and see what would happen. So, yeah. I think that's going to happen with these kites as well. We're going to see if they fly or not.
So we take information plus the iterative design process, combine them together to teach students creative problem solving and critical thinking. We see our curriculum as an avenue to teach students an optimistic way of thinking about the world's problems and feeling the confidence that they have the skills to go out and come up with solutions.
One critical component of the K-12 curriculum is to engage the students in regional environmental issues in the context of global environmental crises. And this does two things. It allows students to build sustainable competencies in their region, and it allows them to feel connected to a global community.
We see this curriculum as applicable anywhere in the world. We are planning to tie in third world technologies that could exist anywhere in the world. They don't just have to be renewables that we can use here. And we see this curriculum as teaching students to see themselves as global citizens. These sculptures are going to encircle the globe, metaphorically connecting everyone around the world as we are connected by our climate, by our oceans, and by our atmosphere. We have found there's a huge willingness for businesses and professionals and academics to come speak to the kids and help mentor them and connect to them around this issue of solving a global problem. So it's really all hands on deck. We see this solution as being far beyond one particular sector of our community or beyond one subgroup being able to solve it. We all have to work together. And students are really getting that message.
Well, it created an entire, a qualitatively different experience, trying to create something, or even just in the attempt at designing something that would overcome a problem, right, as opposed to talking about it. Well, very rarely in school do we actually deal with the environment, and I mean, we talk about it, right, but we never really think about it in detail enough to actually, you think about it and you maybe talk about it, and you talk about the ramifications of environmental change and global warming and such, but you don't actually try to come up with solutions, or you don't really think about ways to change it. And I think that this was an example of taking one's philosophy and actually doing it.
The Energy Necklace Education Project really is an invitation to participate in a global effort to find a solution to these environmental crises. And it's a message of hope. It's a message of positive contribution. It's a message of collaboration.